Hey guys, welcome back to my YouTube channel Med Edophilia. In today's video, we will be solving few questions on the chapter that we had discussed in physics, that is units, measurements, dimensions and errors. So I will be sharing with you few important models of questions, and along with that I will be sharing with you the tips and tricks in order to crack the question under a minute. So let's get straight into the video. So before solving a few questions, let's first look at some important hints for solving questions related to dimensions. So always you hear a term density along with some physical quantity. For example, energy density. Let's say whenever this word comes, it means that there is a volume term divided. Okay, so here energy density means energy by volume. So how do you find the dimensions of energy density? It's nothing but ml square t power minus 2 by L cube volume. So it's L cube, length cube is equal to, while solving, what will you get? ml power minus 1 t power minus 2. So this is nothing but the dimensions of energy density. Whereas when you say linear density, what does that mean? This word linear means by length. For example, let's take linear charge density. So this is nothing but the term charge by length. Okay, because there is a term linear accompanying it. So charge by length. So what is the dimensions of charge? We can find it by using the formula Q is equal to IT. Right. So from this we get I. For I, you get ampere. So it's A, and for time is simply T. Okay, and by length, so L power minus 1. Simple. Now let's look at another term, which is linear mass density. So what will be its formula? Simple, mass by length. Okay, so there are a few terms like this where students get confused and they might not know the actual formula, so they end up losing marks on this. Okay, so make sure that you do not commit such mistakes and have a clear understanding what do we mean by linear charge density, linear mass density and energy density and so on. Okay, here there are some words like this where you should know the meaning, what does it actually mean. So when you know this, the dimensional formula of this becomes extremely easy. Okay, now let's move on to solving our very first question. Okay, so I give you the question as, if v is equal to alpha t plus beta root t, then find the dimensions of alpha and beta. That is your question. So we know from the principle of homogeneity that only quantities, that is quantity in the right hand side should be equal to, that is dimensions of the quantity in right hand side and the dimensions of the quantity on left hand side should be equal, and only quantities with the same dimensions can be added or subtracted. So using the simple rule, we can say that dimensions of this term velocity, which is on the right hand side, and dimensions of alpha t and beta root t should all be the same. So we can simply equate the dimensions of velocity, that is L t power minus 1 is equal to alpha, and t is nothing but simply time, right? So alpha t. So on solving, what will you get? The dimensions of alpha as L t power minus 2. Similarly, for take beta root t term and equate it with the dimensions of velocity. Again, what do we get? We get beta's dimension as L t power minus 3 by 2. So this becomes our final answer. Now let's look at the next question. So this question was asked in NEET 2016. The question goes as, if Planck's constant h, speed of light in vacuum c and Newton's gravitational constant g are taken as fundamental quantities, then which of the following has the dimensions of length? So this is our question, and here are the options. Four options are given. So the very first term given in the question, what is it? Planck's constant. So we would have known this well-known formula, that is E is equal to h nu from Planck's quantum theory. So from this we can find the dimensions of h, Planck's constant. Okay, so h is nothing but energy by frequency from this formula. So for energy we know dimensional formula is ml square t power minus 2. For frequency is nothing but the inverse of time. So by t power minus 1. So what do we get? We get ml square t power minus 1 as the dimensional formula of h. Now the next physical quantity given in the question is the speed of light in vacuum, that is c. So that is nothing but the velocity. So we know that the dimensional formula for velocity is nothing but Lt power minus 1. Okay, so the next physical quantity given is gravitational constant. So which formula does which formula is there in which g is present? So you should always try to, whenever you see a new physical quantity, you should always try to recollect any formula that contains that particular physical quantity. So we know from Newton's law of gravitation, we know this famous formula that F is equal to g m1 m2 by r square. So this equation, this formula has g term in it. So from this simple formula we can find the formula, dimensional formula of g as well. So for you can express this as F into r square by m1 m2, right? So for dimensional formula is force is ml t power minus 2. Dimension of r square is nothing but length square by m1 m2, it's nothing but m square. On solving you will get m power minus 1 l cube t power minus 2 as the dimensional formula of g. Okay. Now in the question they have given that length, you have to express this length as in, that is in terms of h, c and g. So we can say that length is directly proportional to that is it depends on h to the power x, c power y and g power z. Okay, and using our usual method we can express this. So what do we get? L is equal to m L square t power minus 1 whole power x, L t power minus 1 whole power y, m power minus 1 L cube t power minus 2 whole power z. This is what we get. So when you open the brackets and put the powers for all the terms of m, L and t, what you get is, on combining all the terms on m together, you get x minus z, and equate it to that in the left hand side. You can equate it to 0 because there's no m term, right? So x minus z is equal to 0. So on this solving you will get x is equal to z. Similarly equate the powers of L. On the right hand side you have 2x plus y plus 3z is equal to 1. That is a power of L on the left hand side is 1. So solving you get 5z plus y is equal to z. Similarly for time, minus x minus y minus 2z is equal to 0, minus 3z minus y is equal to 0. So you get three equations on equating the powers of m, L and t on the left hand side and right hand side. So what you should do is solve all these three equations. So when you substitute this x is equal to z in the other equation, you will get 2z is equal to 1 and z is equal to 1 by 2. Similarly, you can find x, y. So you get x as 1 by 2 because x is equal to z and y is minus 3 by 2. So finally, you can express length as under root h g by 3 by c to the power 3 by 2. So that's the method. Okay, now we move to the next question. So the question goes like, if E, V, T are fundamental quantities where E is the energy, V is velocity and T is time, then dimensional formula of surface tension. They are asking us to find out the dimensional formula of surface tension. So very first step is to write the dimensions of E, V and T. E energy is ml square T power minus 2 as we all know. Velocity discussed n number of times, Lt power minus 1 and time simply T. So surface tension is nothing but force per unit length. So you will learn in the chapter of fluids. Okay, so force per unit length, so force is ml power minus 2 by length, okay, by L. So you get surface tension dimension formula as mt power minus 2. Now you have to simply equate and find out the value of x, y and z by equating the powers on left hand side and right hand side. On equating you get the value first being m, there's only one term, you can simply easily equate, you find x as 1. Similarly, you can write minus 2 is equal to minus 2x minus y plus z, and you can substitute the value of x here and find y is equal to z. You get this as the final thing. Next, moving on to the third equation, you get 2x plus y is equal to 0, and then we can find y to be equal to minus 2 because x's value is 1, isn't it? So y is equal to minus 2 and y is equal to z is equal to minus 2. So we found the powers, the value of powers, that is, then we can substitute in the actual equation. So surface tension's dimensional formula in terms of this fundamental quantities, the energy, velocity, time, is E v power minus 2 t power minus 2. Do you understand? Okay, so that's how you solve. So the basic concept is same throughout for all the questions. It's the same procedure. Okay, now I'll give you another question for practice. This was a previous question, so let's solve. It's given that length depends on e square by 4 pi epsilon naught c g as what? They have given the relation. Okay, these are the options. So you have to recollect, and the first job is to find out the dimensional formula of the physical quantities given in the question, isn't it? So this you have to remember and recollect, where does this e square by 4 pi epsilon come? Okay, so when you recollect, this comes in this equation, f is equal to k q1 q2 by r square, where k is 1 by 4 pi epsilon naught, isn't it? So from here we get this equation. So this e square is nothing but one electron charge. So same thing, e square, q square, everything is the same. So when you recollect this thing, when you find out, okay, for this physical quantity you can use that formula, everything will become easy. Finding the dimensional formula will become easy. So that's your first job, finding the dimensional formula. So you can write e square by 4 pi epsilon naught as f r square. This will make your job easy. Instead of finding the dimensions of charge and then squaring it and then finding dimensions of epsilon naught and then dividing it by the dimensions of e square, it's all a big procedure. So simply recollect where this whole term comes. Did you study this in any of the formula? Okay, try to recollect, then apply. Okay, so on solving this, you get this e square by 4 pi epsilon naught's dimension as ml cube t power minus 2. Then similarly, you can find the dimensions of gravitational constant. I told you, you can use f is equal to g m1 m2 by r square and find the dimensions of g. So what do we get? As we discussed in the previous questions, we get m power minus 1 L cube t power minus 2. And again, c, dimensions of c is nothing but velocity, so it is L t power minus 1. So the same thing, you express length as ml cube t power minus 2 whole power x, m power minus 1 L cube t power minus 2 whole power y, and Lt minus 1 whole power z. Again, you have to equate the powers, okay, and you get three equations. And what do? You have to solve them. So I want to ask you honestly, don't you find this extremely lengthy? Do you think you'll have all the time to solve this question fully like this? Writing each dimensions, each calculation, solving all the three equations like this? No, you will, if you solve like this, you will not have time to complete your neat paper. That is why students find neat lengthy, and they, even if they know the answer, they will not be able to share it in their OMR. So this will become a great problem. So please do not follow this conventional method. Of course, this is the right method, and many students have been following this age-old method. Okay, what I recommend you is to do your smart work here. Okay, so you have to save your time. So what you can do, just simply observe the question and observe the options. So here, after writing the dimension formula of c, g and e square by 4 pi epsilon naught, what do we find? What do we actually want? We need to express this in terms of length, like only length. Okay, so there's just no mass term. So using these three quantities, what should you do for removing the mass term? So simply, there is no mass term in C anyway, so you leave it. So this, you are only left with g and e square by 4 pi epsilon naught. So there is m power minus 1 in G, and there is m power 1 in E square by 4 pi epsilon naught. So simply when you multiply, the m term will get cancelled. So just see the options in which G and E square by 4 pi epsilon naught are getting multiplied. So you can easily eliminate the other options. So by doing this, two options are getting eliminated easily, isn't it? So finally we need only length as our answer. So we do not need mass, and we also do not need time. So look at the options. Can we eliminate and remove time by either multiplying or dividing? No chance. We cannot remove or multiply or divide, isn't it? So what should you do? We find that t is not getting cancelled anyways. So now again check the options. You find that this G E square by 4 pi epsilon naught is common in two options. So this G E square by 4 pi epsilon naught whole power 1 by 2 is common in two options, that apart from what we have eliminated. So simply find the dimensions of that common term which is common in both the options. So L cube t power minus 2, okay, is what we get when you do whole power 1 by 2. Now compare with the options. What do we have? Take one of the options. Okay, there is 1 by c square to that option. So substitute. That way you can check one of the options and find if you are getting length. So when you do 1 by c square, you will get L square t power minus 2. You have to divide that. So you easily find that it's getting cancelled and you're getting length, right? So simply you can say that this is the correct option. So the answer is 1 by c square G E square by 4 pi epsilon naught whole power 1 by 2. This is the answer. So did you understand how quickly we got the answer without doing those lengthy calculations, solving all the three equations? No, we didn't do any of that. We just wrote the dimensional formula of the physical quantities given in the question. That is one thing, because the chapter itself is dimensions analysis. Okay, so that is the main concept. So you cannot skip that step. So writing the dimensional formula is the first step, and then looking at the question, what are they asking for, and comparing the answer with the question and seeing if any term is getting cancelled. What should you do for that, for that term to get cancelled? So that is what you need to do. So using the simple mind calculation itself, you can crack this question of dimensional analysis. So let's solve the question which I discussed earlier, which is again a lengthy question which you had to solve all the three equations. Let's solve that question using this simple mind calculation. Okay, so this question is what I was talking about, that the Planck's constant, speed of light in vacuum, and Newton's gravitational constant. You should all take this as the three fundamental constants, and you should express length as taking these as the fundamental quantities. Okay, so first step, write the dimensional formula of all this, and after that what should you do? See, what should you see? If you need to express this as length. Okay, so what should you see? Whether if you multiply anything, the m term or the t term is getting cancelled or not. Simple. What should you do? See h and g, it's m power 1 and m power minus 1. So what should you do? You should simply multiply them, because there is no m term. So you multiply them. So h and g should be multiplied, that is for sure. So you can eliminate the options in which both are not multiplied. Look at option C and D. H and C, H it's given as h by g in option C, and D g by h. So absolutely it's wrong. So the options could be either A or B. Simple. Okay, now both options given as under root hg. Okay, so find the dimensions which is the common term in both the options. So what is the dimension formula of under root hg? You will get L power 5 t power minus 3, and when you do under root, you will get L power 5 by 2 t power minus 3 by 2. Okay, now what should you take? What should you do? Just take one of the options. Say for example, I'm taking option A. Okay, there is one c power 3 by 2 in the denominator. So just divide and check with the options. So when you do c power 3 by 2, you will get L power 3 by 2 into t power minus 3 by 2. So when you divide easily, this t power minus 3 by 2 is getting cancelled. Then L power 5 by 2 minus 3 by 2, bring it to the numerator. Minus 3 by 2, you get L power 2 by 2, which is nothing but L power 1, which is nothing but length, which is what is being asked in the question. So what is the correct answer? It is option A. So how long did it take? Just less than 1 minute, 30 seconds only, or max just 1 minute it would have been. So don't you think this method is extremely easy? Yes. Okay. So now let's move on to the next question. Find the dimensions of nu naught epsilon naught whole power minus 1 by 2. So this you need to find. This is a straightforward question. They have given a random physical quantity with their multiplied or divided and raised to the power of something, and we have to find the dimensions of it. So where have you come across this nu naught term? In this formula, magnetic field. What is the formula of magnetic field? Nu naught by 4 pi m by r cube, where m is the dipole moment, isn't it? Magnetic dipole moment. And similarly, you have this electric field. I'm sorry, the force, electric field force. Okay, it is the force of attraction between Coulomb's law of force of attraction between two charges. What do we get? There is one formula you have learned, isn't it? 1 by 4 pi epsilon naught q1 q2 by r square. So from this we can find the dimensional formula of epsilon naught and nu naught, and then simply do it whole power minus 1 by 2. So this is a long procedure. Okay, doing this is an utter waste, I would say, because this will eat up all your time, and this will not be, you will not be able to solve the other easy questions. Okay, so this is a wrong approach. Okay, because it's very lengthy to do this in this method. What you have to do is take it, look at the question as a whole. Nu naught epsilon naught whole power minus 1 by 2. What can you write this as? You can write this as 1 by nu naught epsilon naught, 1 by under root nu naught epsilon naught. Where have you, is there a formula? Direct formula you would have learnt in electromagnetic waves, isn't it? C is equal to 1 by nu naught under root nu naught epsilon naught. Yes. So your question becomes simplified. So the answer for this whole term lies in the dimensions of c, dimensions of velocity. So the answer is nothing but Lt power minus 1. Simple. Okay, you don't have to, so always try to look at the question as a whole and try to recollect if this is present in a formula as such, which you have learnt. So EM waves is again a small chapter, so you can expect questions like this. So do not skip that chapter. That is also important. So this is how you will be tested. So if you are in class 11, you're just starting, you might not know these formula. So you might, do it in the old conventional method, or some people just end up mugging up the dimensions of nu naught and epsilon naught. So please don't do that, because ultimately in the end of your NEET preparation you will come to know all the formulas involved in physics. So at that time you need to revise this chapter once again so that you get a better grip. You will know how to save time and solve questions in a better way. Okay. Okay, so let's look at one more question. Okay, it goes as equation for stationary wave is given as y is equal to 2a sine 2 pi ct by lambda cos 2 pi x by lambda. Which of the following statements is incorrect? Option A, unit of ct is same as lambda. Okay. Option B, unit of 2 pi c by lambda is same as 2 pi x by lambda t. Okay. Option C, unit of x is same as lambda. Okay. And option D, unit of x by lambda is same as c by lambda. Okay. So you have, what they are asking, which of the following statements is incorrect. So always whenever there is the term incorrect, correct, except, okay, not, okay. You always have to circle or underline these words, because these are the words which will determine, okay, whether you're going to get that plus 4 marks or not, because you tend to make silly mistakes in such questions by overlooking the question and not reading the question carefully. So always circle it or underline it so that you do not commit this mistake, okay. So let's look at the very first option, A. So lambda, we know its wavelength, so it has the dimensions length. Talking about CT, speed into time, which is nothing but distance. So again, distance has the dimensions length. So when the dimensions is same, even the unit is going to be same. So you have to solve everything by dimensional analysis. Okay, look at option B. 2 pi c by lambda. So ignore that 2 pi, the constant 2 pi. So what you have to see is c by lambda, speed by distance. What is speed by distance? It is the reciprocal of time. It's 1 by t time. Okay. Now look at the other term. 2 pi x by lambda t. So just look at the physical quantity x by lambda t. X is distance, lambda again distance, so cancelled. So again you're finally left with 1 by time. 1 by time. So both sides you get 1 by time. Same. So it's same dimensions, same unit. So option B is also correct. Look at option C. Unit of x is same as unit of lambda. Isn't it obvious? X is distance, lambda is wavelength. Both correspond to length. Simple. So it is correct. Option D has to be incorrect. But anyways, let's check. So unit of x by lambda is same as c by lambda. What nonsense. You have lambda, which is common, which is present in the denominator, and x on the top, c on the top. X is distance and c is speed. So definitely the dimensions of them will not be equal. Okay, so this is incorrect. So now let's start discussing about errors. We are done with dimensions, dimension analysis. Okay, so now let's move on to errors. Before that, let's look at some hints and tricks for solving problems related to errors. So first thing I would say is discussing about errors when resistors are connected in parallel and series. So you know this formula for parallel connections. What is the equivalent resistance in parallel connection? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus so on. That's how you find Rp. So for two resistors in parallel, what do we have as equivalent resistance? R1 R2 by R1 plus R2. Okay. So just remember this for finding fractional errors, okay, and for finding percentage errors in the equivalent resistance when they are connected in parallel, especially for two resistors. You can use this formula, that is del R equivalent by R square equivalent is equal to del R1 by R1 square plus del R2 by R2 square. Simple, just remember this and your error related problems will become easy. In series, this is very easy. R equivalent is R1 plus R2 plus R3 so on, sum. So error in the resistance when they are connected in series also, del R equivalent in series is equal to del R1 plus del R2 plus del R2, because errors are always added. We have seen earlier. So for series it's simple. So only thing you need to remember is for parallel. So let's check. Okay, check out one question. They have given two resistors R1 and R2, where R1 is given as 50 plus or minus 2 ohms, R2 is given as 100 plus or minus 3 ohms, and they are connected in parallel. So find out the relative error, okay, in the equivalent resistance. So that is our question. So what do we have? We have this formula, we just looked at it now. So when you transport this R equivalent to the right hand side, you will get the fractional error formula, that is del R equivalent by R equivalent. You get this. So that is equal to del R1 by R1 square plus del R2 by R2 square into R equivalent. So first step is finding R equivalent by using the formula R1 R2 by R1 plus R2 for two resistors. So 50 into 100, whatever is given in the question, okay, by 150. When you solve, when you cancel, you get 100 by 3. Delta R1. Okay, what is given in the question is given plus or minus 2 plus or minus 3. So The error is 2 and 3 here. So it's 2 by r1 square 50 into 50 plus 3 by r2 square 100 into 100 into r equivalent 100 by 3. Okay, you can cancel out this 100 term which is common in both. Okay, in all things you can cancel out the two zeros. So you solve, take the LCM as 100. Okay, this 1 by 3 is common over here. So it become 8 plus 3 by 100 into 1 by 3. 11 by 3 by 100 by 11 by 100 into 1 by 3. So solve this, you get the answer as 0.036. So that is our fractional error or relative error in the equivalent resistance when they are connected in parallel. So this is the one thing which I wanted to tell while discussing about the problems related to errors. So rest all types of problems we have looked at in the lecture of errors and measurement, in that lecture which I posted previously. So you can check out that. So almost all models are covered. So now we are only left with problems related to vernier caliper and screw gauge. So I told you I'll be discussing the formulae related to it so that your problem solving will become easier. Okay, so you just have to remember two simple formulae related to vernier caliper. First one, least count. What is the formula of least count? 1 main scale division minus 1 vernier scale division. That is the formula for least count. Second formula you need to remember is the length of the object. How do you measure the length of the object using a vernier caliper? First one, you have to add the main scale reading, whatever you get as the reading in the main scale, and you have to add the vernier scale reading. So the formula of length of an object is main scale reading plus vernier scale reading into least count. That is the formula. So these two formulas and problem solving will become easy for you. Next one is screw gauge. In screw gauge again there are two formulas only. Remembering this, your job of solving will become easy. First one is the formula for pitch. Okay, for pitch it is defined as the distance moved by the screw per unit rotation. Okay, so pitch is nothing but distance moved by the screw by the number of rotations. Second formula you need to remember is the least count. That is, least count is equal to pitch by the number of divisions in the circular or head scale. Okay, head scale, circular scale, both are the same. Then again, if you want to find out the readings, okay, the length of the object measured, it's the same as that which we saw in vernier caliper. Okay, so main scale reading plus here instead of vernier scale reading, you have to do circular scale reading. Okay, you have to do that and into least count minus the error, whether it's positive error or negative error, you have to always do minus the error. Okay, so we will discuss few problems so that these two formulas will get into your mind easily. So let's look at the first problem. 1 centimeter on the main scale of vernier caliper is divided into 10 divisions, 10 equal parts. If 20 divisions of the vernier scale coincides with 10 divisions of the main scale, what will be the least count of that vernier caliper? So what is it given in the first line of the question? That 1 centimeter on the main scale is divided into 10 parts. So 1 by 10. 1 centimeter is divided into 10 parts. So 1 by 10, 0.1 centimeter. So from this we understand that 1 main scale division is 0.1 centimeter or 1 millimeter. That is the first thing which we can obtain from the question. Next, they have given 20 divisions of the vernier scale coincides with 10 divisions of main scale. From this, we can find how much is one vernier scale division in terms of main scale division. So, on simple cross multiplication, you get 10 by 20, which is 0.5 main scale division. Main scale division, we know one main scale division is 1 millimeter, which we just found out. So, 0.5 into 1 millimeter, which we get 0.5 millimeter. So, least count is nothing but simply apply the formula 1 MSD minus 1 VSD, 1 main scale division minus 1 vernier scale division, which is 1. 1 main scale division we found it as 1 millimeter minus 1 VSD, which is 0.5 mm. So subtract, you get 0.5 mm as the final answer. Okay, so now let's look at another question, a little different type, and let's see how to solve them. Okay, a vernier scale with 0.02 mm least count is constructed. Okay, if 1 MSD is 0.5 mm, then how many divisions would the sliding scale have? So here the sliding scale is nothing but vernier scale, that is what they are talking about. So how do you solve this question? For this you have this formula. Least count is equal to value of 1 main scale division by total number of divisions in vernier scale. So if you remember this, then the job is easy. So they have given us the least count and they have given us the value of 1 main scale division. What have they asked? They have asked us to find out the total number of divisions in vernier scale. So simply multiply simply cross multiply, and what do you get? Bring it to the other side. You get 0.5 by 0.02, and solving you get 50 by 2, which is 25. So there are 25 divisions present in the vernier scale. Now let's look at a question about screw gauge, which was asked in NEET 2020. A screw gauge has least count 0.01 mm and there are 50 divisions in its circular scale. What is the pitch of the screw gauge? And they have given us 4 options. So simple direct formula, we have this formula of least count, which is equal to pitch by number of circular scale division. So what do we get? The answer as least count into number of circular scale division, 0.01 into 50, which is 0.5 mm. Simple. So answer is option B. So this is all about the problems on vernier scale division and scale of screw gauge. So questions from these topics are mostly formulae based, especially from the formulae which I gave you now, just the 3 or 4 formulae. So just go through them and the questions will definitely be simple. And if you still want more concept clarity on vernier scale, screw gauge, and you want more questions on the topic, you can comment below. Definitely I will make a video or separate video on that. Okay, so this is it. We have come to an end on the session of question solving on the chapter units and dimensions. So keep practicing more MCQs to build your concepts, get your doubts clear. Thank you so much. Stay tuned. Let's meet in our next video.